Hello, and welcome back to the channel. For today's video, I'd like to present a couple of tools that I purchased to help me with my projects. I won't be recommending any of these, so I won't be linking them in the description. If you really would like me to share where I got them from, please request for them in the comment section below. The first one I'd like to show is this electric screwdriver by Works. Uh, this winter felt longer and colder than the past winters I've had. The cold weather has made my arthritis kick in more than a few times, so it drove me to get one of these. I don't normally like using an electric screwdriver for my projects because I don't want to over tighten certain things and end up breaking something. I want to be able to feel how tight I've screwed something in. Although this one does have a torque setting, and I could probably just set it to the lowest torque and tighten whatever it is the rest of the way manually. I got it for under 40 US dollars. The reason I don't want to recommend it is that the tools that I normally use won't fit in the hex hole. I bought this. I bought another. These are also some cheapo tools that I got from like AliExpress. Not sponsored by them or anything. So what I was trying to say is this don't fit in there. So I had to design and 3D print an adapter to be able to use my tools. I printed a few of them in case the adapter breaks. I could just replace it or print new ones. I need to put a magnet in the bottom of the shaft tool so the tool won't fall out. Um, there are far better products out there, but this one's the best one that I could afford or want to pay for. So this one does have, like I said, have a torque setting. And what was kind of janky about this is normally the one or the line is the on button or close button, and the O or circle is the open button. But it's reversed for this one. So the O or circle is the on button. It does have a nice light at the tip here, so you'll be able to see whatever you're screwing into. And this thing ejects the tool pretty easily. Yeah. I'll see if I could hold down and demonstrate that the torque does vary when you change the torque setting. So I'm going to try and hold this. Let's set it to 2. Still stops, and then let's try 3. I can't stop it after 3. I have used it. I've had to take my laptop apart, and I've tested setting 1 and 2. Uh, it was set to 2 earlier because that's what it had more torque. The torque that I needed to tighten the screws. So it's nice. I mean, although I'm not recommending it, it's still pretty nice. Fairly cheap. But like I said, I think there are far better tools available out there. The only thing I didn't like I said, it didn't have the adapter for what I need or want it for. There are other tools that came with it, or tips that came with it, and it does have this adapter for these smaller ones, but it won't fit my tool. That's too small, so it's just I can't find in between. Still pretty nice, but still not recommending it. Let's turn that off. The next one I'd like to show is this micro lathe. At first I wanted to return it because the shaft through hole, it's too small for what I want to use it for. I can't even fit a 8mm uh, round stock in there. So I thought about getting an actual mini lathe that's far more capable than this. But I have limited to no bench space for a mini lathe. This would have been the ideal dimension for me. I only wish that the shaft through hole is twice as big. Still, I've decided to keep this and make a project out of it. And to be honest, I've already started a little bit of an upgrade for it. Out of the box, there was no RPM control for the motor. It has a currently has a brush motor, so basically it was just either off or on. I installed a PWM motor speed controller. It's good for 6 to 24 volts DC and up to 8 amps. I 3D printed this housing for it, which I think looks like it belongs there. The only thing about it is the only thing I don't like about it is that it turns on automatically as soon as power is applied to it. So as you can see, as soon as I plug it in, when power is applied to it, it turns right on. So I'd have to make sure that the potentiometer that controls the motor is turned on all the way. I don't know what the purpose of the on off button or switch is. Then I guess I could treat it as an emergency stop. In that case, I could probably redesign this housing and you know put the button on the top. I don't know. Or maybe I could just leave it as is because I plan on upgrading the motor anyway with the brushless type, which would have more torque. Um, I'd lose the digital display though, unless I figure out how to merge them together. I'm not sure how to do that. I don't have the knowledge how to do that currently. What I wanted to get a lathe for is to turn some rods to make my own steering links and suspension arms. Also, I wanted to do some machining for my cloudbuster axle shafts to be able to fit the limited slip differential that I've designed for it. And there's also some things that I want to try and do for the juggernaut differential to be able to make them hold fluid. I want to put a couple of grooves on the inside and place O-rings inside to seal the holes and prevent fluid from leaking out. So for now I want to demonstrate how this works. So right at about 7% ish, it'll start spinning. This is percentage, not RPM. And it goes all the way up to 100%. And what's surprising is that, yeah, it's not that accurate, but I can get the runoff really close to, I think, about a thousandth of an inch. Um, One of the chuck is kind of low, so that's what this piece of paper is for. I'd have to put it on chuck one, and to be able to basically raise that jaw and get the runoff um, higher, raise the runoff and make it more concentric. Let me see if I can demonstrate. Let me bring you guys in a little bit closer here, and I'm gonna try and spin this. This is kind of hard to demonstrate because the base of the micro lathe is nothing is magnetic, so I can't get the dial indicator to stick to it. So it's just sitting on this folding table. But what I'm trying to do is spin the. I'm gonna try and spin the spindle and see how much runoff we get. So right now we get a maximum of 6 thousandths of an inch. Like that's a high point and a low point of about 2.5 thousandths, three, what? No, 2.5 thousandths of an inch right there. So what I'm gonna do next is put that piece of paper on jaw one of the chuck. Now let's check our runoff. So I think we're a little over 1 thousandths of an inch. Which is, to me, that's not bad. Um, that surface of that tool is also not that, probably not that perfect. Um, it has some letter letter engravings on there. Basically tells me what size the tool is, but I'll try to move it away from the engraving. So, I mean, that's not bad for this toy-ish lathe. Um, I had purchased another chuck for it, but this one has a worse runoff than that other one. So, um, I was hoping that this was gonna be better. This is a lot heavier than that, and I thought it'd be more uh, accurate, but unfortunately not. That's This is the one that came with stock with the lathe, and it's fine. But what what's good about buying the second one is, let me zoom you guys out. This one will fit in the tailstock. So I can now use this as a, and maybe like a drill bit holder, and make a hole, bore out something that I'm trying to run in there. I'm just gonna have to, dial this up a little bit. I can probably, do it off camera and see where the high points and low points, etc. is. If I have to shim it like I did this to get it a little bit more concentric. So before I, chuck up a drill bit on here, or I'm trying to bore something, it'll be more centered. While I'm at this, I want to discuss the progress with my Tamiya Juggernaut differential. So the idea came to me why I want to put um, O-ring, why I want to put grooves on the inside and put O-rings on the inside is from the 3D prints that I've designed. So this, I'm gonna zoom you guys a little bit, and I'm gonna take this thing out of the way. So this has been sitting in the axle for about a week now or so, and I have not seen any um, leaks coming out of it. So this design, this actually has O-rings on the inside, which is preventing the fluid from leaking out. There's also an O-ring, as you can see the black things thing that's wrapping around it. There's an O-ring that's sandwiched in between the two that's preventing the fluid from leaking from this seam. So I put the silicone differential in it. I went with the 60K because I think that's plenty um, tacky enough, or for the Juggernaut, and it still spins. It's not, you can see it's not locked. So, but it is a little bit more difficult to spin. I don't hear any. I don't hear any like grinding noise. I'm gonna bring this to my microphone, and I'm spinning it right now. What you're hearing is probably just like my hand like gripping on it. I don't know if you guys can hear it, but this I don't see any leaks coming out of it. So I wanna um, finish up this project and do the same thing for the other axle. So yeah, just I didn't want to do two at the same time. I wanted to do one at a time and um, do the experiment. So if you can see like those two dashes, obviously there's I put the three other joined together. There's three screws, and this was the best alignment that had the least amount of wobble for the gear. I mean, there's a slight wobble there, and this is the least amount of wobble. um, this is so. What I'm gonna do is try and see if I could get this going, and try to get my Juggernaut back on the back on the road. Oh, so real quick, I have two different types of power uh, for this lathe. So this is the stock one. It came as a output of this is 12 volts DC and 5 amps, uh, up to 5 amps of amperage. The other one I have is you guys aren't probably gonna see this, but it's actually 20 volts. Right here tells me it's 20 volts, um, 6 amps. Um, so it has a slightly more amperage and voltage, and I wanna demonstrate real quick how fast it goes with the stock power, the 12 volts. And I've tried it before. I was able to stop the chuck with my bare hand or slow it down. See, let me try the other power. So here's the one with the 20 volts power supply. I mean, it's definitely a lot faster, but I can feel it vibrating a little bit more, and I don't even want to try and see if I can stop this. Maybe at low RPM. Nope, I can't. I actually can't stop it anymore at 30, 30%. Before at 50, 70%, I can hold it and stop it. And now, as you can see, at 30%, I can't even stop it. So that's a pretty good upgrade, I think. So, but so that's what's going on with the channel, and I'm hoping to move forward with the Juggernaut project. Hopefully, I get that running soon, and it's starting to get warm. Hopefully, to get a running video and test the differential, and then hopefully move on to the next project. If you have any suggestion for the channel, please let me know in the comments below. And if you like my videos, please share them. Thank you for watching.